Let's start talking about the second chapter, which is IoT. When we talk about IoT or the Internet of Things, we actually mean a large collection of physical devices that communicate with each other without any human intervention. Each device on the IoT network is basically what we call it as a thing is a physical device, appliance, or gadget. And these gadgets or these devices communicate with each other, exchange data using different type of technologies like Wi-Fi, Bluetooth, Zigbee, cellular, or and then many more options. So the major like we have the internet where we humans are communicating with each other. Internet of Things is basically an internet where the different physical appliances communicate with each other. And of course, when this is happening, there are concerns for security. Then there are privacy issues as devices are collecting our data, and this data that is collected by the devices can be misused or by malicious intentions of the people. And this data collection and can be done for sale purposes. Our data could be sold for scrupulous purposes. So it is very important for users to be aware and educate them about IoT security and privacy best practices. So, all these devices that we are talking about, the smart devices, for example, we have a smart refrigerator, we have a smart TV these days, we have so many in our home, we have so many smart devices. All these devices are equipped with sensors. Now, what are these sensors? These sensors are designed to detect and respond to changes in the environment. For example, you have an air conditioner. The moment the temperature increases, it starts its work, starts cooling so that the temperature goes down again. Similarly, we use different types of sensors to identify the variations in light, temperature, motion, moisture, and other physical properties. And these sensors play a crucial role. For example, the proximity sensor is if suppose there's an autonomous vehicle and there's an obstruction, there's something lying down on the road. So proximity sensor would do its job to identify that there's an object. Then we have temperature sensors, we have vibration sensors, then touch sensors, moisture sensors. Similarly, we have water quality sensors to identify the quality of the water that we are getting. We have chemical sensors which detect the presence of certain chemicals. We have gas sensors which can identify the presence of bromine, carbon dioxide, carbon monoxide. So different nitrogen oxide, dioxide, nitric oxide, ozone. Then we have smoke sensors. We have turbidity sensors. We have pH level sensors to know the acidity or of soil. Then we have infrared sensors. So we have different type of sensors that can be used with our devices when we make an IoT network. So several factors influence the sensor's transfer functions. So for example, we will now study about some factors which affects the working of sensors. The first is sensitivity. Now, as the name suggests, sensitivity is the ability to detect even the slightest change in the stimulus or quantity being measured, how accurately, precisely you can do it. Then the range is a crucial parameter for sensors as it detects the extent of their operational capability. For example, in Bluetooth, the range is maximum 10 meters, not beyond that. When we talk about accuracy and precision, what exactly do we mean? So when we say accuracy, it refers to how close a measured value is to the true or accepted reference value. For example, if I say your marks is 98%, but actually it was 99%. So it was almost accurate. So how close it is to the accurate value. And precision means the repeatability or consistency of measurement. For example, if I say you got 99%, but today I'm saying 99, maybe tomorrow I'm saying 70%. So there is no precision. So here there are two parameters, accuracy and precision. Now, these factors depends upon calibration. Environmental influences wear and tear, noise, and quality of components. Of course, the quality of components decides how much your sensors can accurately collect the data. Right? Noise means external noise. For example, the sensors were working properly, but because of an external interference, it could not do its intended task. Wear and tear with like age. For example, if you're using a sensor for too long, so the readings might not be that accurate. When we say environmental influences, we mean presence of moisture, humidity, temperature may affect the precision of your sensors. Then calibration means there are variations in the readings, right? So there must be some adjustment done to make the readings accurate. Then other factors are response time. Of course, the moment you sense there's a change, the sensor should respond with slightest delay. So hysteresis. Now it is particularly when they encounter fluctuating inputs. Sometimes there are fluctuations. So when you have fluctuating inputs, so that causes inconsistencies in readings due to delayed responses during varying input conditions. Right. Then resolution. See, what is the difference between hysteresis and response time? Response time means it is consistently the delay is there or not there, whatever it is. Response time is high means there are delays, and if response time is less, there are less delays, right? But hysteresis is just because of fluctuation in the inputs. Then resolution denotes a sensor's ability to detect and respond to even slightest change in the measured quantity. It is simply the smallest increment of the measured parameter that a sensor can reliably detect and display. For example, if we say that this particular device can detect noise of 20 decibels, so that is its resolution. Below that, it cannot hear that noise. Then linearity and non-linearity. As it's evident from the graph, a sensor is said to be linear if its output changes proportional with changes in the measured quantity. So it's a straight line, but it's just a straight line means an ideal situation which does not exist in the real world. So non-linear linearity refers to how much a sensor's actual response deviate from the ideal linear response. Stability and drift. In the dynamic field of sensor technology, ensuring stability and reliable results is crucial. So now, but there can be variations because of drifts. And why is this drift? Drift refers to an unwanted shift in sensor's output when the input remains constant. This variation is typically occurs gradually over long periods, can result from aging as well as environmental factors. This means there is a variation in the output that is expected, and this variation is probably due to aging reasons because the prolonged use of a sensor, right? So the output is no more stable. Then, understanding IoT, when we talk about its use cases, IoT system operate by collecting data through sensors embedded in various devices. This data is then transmitted by an IoT gateway, which serves as the central hub. The gateway directs the data to the application or backend system. So we understand this diagrammatically. So what is happening? First, the data is collected to the sensors, then it is sent to a gateway, and then from the gateway it is sent to the backend system for analysis. You can understand from this figure the data is collected, then it is transferred to the gateway, and after that it is analyzed. Then this data is collected using IoT devices which has sensors, right? Then on the right hand you see that the data is then sent to a hub or a gateway, and where then it is finally analyzed using smartphones, human machine interfaces. Then we have a lot of processing done in the backend. We'll see it in detail. So when to understand this, we need to know the architecture of IoT. In the where we have, it's a basically a layered structure. The first layer in this architecture is the perception layer, where we convert analog signals into digital data. The perception layer is the initial stage of an IoT system encompassing a wide range of endpoint devices that bridge the real and digital worlds. Then we have the connectivity layer. Connectivity layer, as the name suggests, it receives data from the first layer, the perception layer, and transmit it to the subsequent layers. It can be done using technologies like 3G, 4G, UTMS, Bluetooth, Wi-Fi, and Ethernet, whatever. Then we have we when to before we process, we need to understand that there is an edge layer or a computing for computing layer. So what do we mean by edge computing? Means the data is processed right at the point where it is collected. For example, if you have a smart car, you have to take the decision then and there itself. For example, to apply brakes or not apply brakes, right? So that is called edge computing. Then we have, let's understand the difference with and without edge computing. So without edge computing, what was happening is the data is collected and sent to the cloud for processing. So when you are transferring data from one end to the other end, there is a lot of delay that is created. But with edge computing, the data is processed at the point where it is collected. So the delay is less. It is more efficient, and uh, outputs can be obtained in real time. So immediate response is obtained with edge computing. Next, now we have the processing layer. In the processing layer, we've already discussed that we collect that data and then we analyze it using different techniques. After the data is processed, it is analyzed, it is sent for, at this layer, information is analyzed by software to answer key business questions. So you have business requirements, and the collected data that is processed is used to answer those questions. Now, in the business layer, you whatever questions, now you have given the answers, now you have to take decisions, right? So the information generated at previous layer brings value when the results in the problem solving and achieving business goals. So now you have the answers, now it is applied in the business layer, it is take action is taken, depending upon, see, so now process the data, then we get answers, and now using those answers we make the strategies, we take the determine, so we make solutions. And the last layer is the security layer, which is the most important layer. So as we discussed, there are different IoT networks. We have the NB IoT, Bluetooth, Wi-Fi. We have Zigbee, RFID. So which IoT network would you use? The question to this answer would depend upon power consumption, coverage area, data amount, device density. For example, if you see, we all use fast tags. In the fast tags, we use RFID, right? Then if it's a, you can, for home smart home gadgets, you can use Wi-Fi. But if it's in a very small area, you can even use Bluetooth. So it depends, totally depends upon these factors, which will on which, based upon which you'll take the decision which IoT network to use. Applications of IoT, if we say, we have smart homes where we have smart devices, we know smart refrigerators. For example, it can tell you when the number of eggs in the egg basket is going, say, below 2, so it will send you an SMS. While coming driving back home, you can bring eggs. So in healthcare, we all wear Fitbits and those smart watches, so that is an application of IoT. Then we have industrial IoT, where in we will study about this in the next section. Then agriculture, may we have IoT sense, we have sensors. For example, as we said, there's a pH quality, water quality sensor. We amount, and then it can also, there are sensors to detect the amount of water present in the soil, so that likewise you can, during irrigation, that data can be used, how much water to put. Then the pH quality of the soil can be measured using this data collected from the sensors. Then transportation and logistics, for inventory management, for smart cities. For example, in bins, you can have, this is recyclable waste, and this is a non-recyclable. For example, if somebody is putting non-recyclable waste in recycled bin, it will, the sensor would generate an alarm. In retail, it is used environmental monitoring. For example, we have air quality sensors, right? So there are different applications of IoT. And why are we using IoT so much? Um, we we all are aware about Industry 4.0, and Industry 4.0 rests upon the use of IoT sensors, data collection and analysis techniques like AI, ML, cloud storage, blockchain. So all these forms the ground for Industry 4.0. So we are using IoT because of cost savings, reduce human error, then allow automation, grid optimization, increase efficiency, increase customer satisfaction, boost employee productivity, and so on and so forth. Then We are also reading about there are smart meters for real-time data analysis, street lighting, for example. If we can use pressure sensors on roads, for if there is a car, if there is even a single vehicle, the street light would be there. The moment there is nothing or nobody or no vehicle or no pedestrian on the road, the lights would be off. Then same we can use smart lighting system in our homes also. If there's somebody in the room, lights would be on. Otherwise, the moment somebody gets out or everybody gets out of the room, the lights would be off. Then waste management, environmental well-being, public safety, right? Um, then, but the issues are about cybersecurity, because see, wherever there is data, it is always vulnerable. The device can always be hacked, right? And data can be accessed for scrupulous purposes. Then scalability. As the number of IoT devices grows, managing the vast amount of data generated becomes increasingly challenged. And do you know that as of now, there are more devices? I mean, if not now, very soon in the future, there will be less people on this planet and more devices, IoT devices on this earth. So just see how just imagine a world where there are more devices than people. When we talk about industrial IoT, that is the application of IoT in industrial sectors. And as we said, the machine to machine communication takes place here for big, and it uses technologies like big data and ML. It is done to enhance efficiency and reliability in industrial operations, and it encompasses applications like robotics, medical devices, software defined production processes for basically for automation. So this was all about IoT, and in the next chapter we will read about the another important topic, that is blockchain.